help you with error messages that might be a little bit better than some of the retro things. And TRS-80GP, if you actually try to do some assembly on a machine, there's no long cassette loads. Things go very fast, and it has graphical debugging capabilities, so you can actually use the emulator to help you debug the programs. All right, we'll get into the demo soon, so hang in there. As far as setting this up on your machine, after lots of discussions and thoughts about this, I finally made a 37-minute video on YouTube, which is linked from the slides here. We'll get the links out about doing this, how you do the emulator installation, the ZMAC installation on a modern machine. So pretty much any machine you have, it takes you through in very simple steps how to set up, how to do path set up, everything you need to. Otherwise, we would spend this entire time on this particular topic. I will definitely mention, these are the sites for these tools, and George does update things quite a bit, many times a year, so it's good to check back when you start work to make sure there's not a new version. And what to do if you really have a TRS-80. So the first way is you need a cassette cable so that your PC will act as a cassette player and you'll play the new program out to your TRS-80. I made a video about making such a cable and how to load things up on a Model 3, so you can take a look at that video. We're not going to, I don't have a Model 3 sitting here, so we're not going to do much of the real thing. And I recommend for a player, this Playcast is really nice online for Windows, and it works great under Linux if you run under a program called Wine, which emulates Windows. But under Linux, you have A-Play and AF-Play on the Mac, which will play WAV files. All right, so this is the big slide. If you kind of remember nothing else, this is kind of what we're doing. The rest of what we're going to do is going to be demos of impressionistic of doing this. So unfortunately, it's a bit of an eye chart, but I'll talk it through. There's kind of a big divide. We have some tasks we're doing on our modern PC. This is our reliable Windows machine over my laptop. And then what we're going to do on a real TRS-80. So let me go over here. The first thing you'll do is edit your program in any text editor you want. You can use Visual Studio Code, you can use Notepad, you can use anything you like that does text editing. I'm going to be using VI, but that's just because I know it. Then you'll assemble with ZMAC. Now, if it gives you errors, you would obviously go back and edit them sort of in a loop. If it doesn't, test it with the emulator. Immediately try this program out, small incremental changes, run it in the emulator right away. Loop back, you can make changes and enhancements. So if what you're seeing running isn't quite what you want, change your code and reassemble. And you'll see this happen in the demos. It's really, really fast. The other side, every now and then, what do we need the real computer for? Well, maybe you don't. Maybe you don't even have a TRS-80. You can still do this. It's perfectly fine. But if you have one, you need to test, you can send it to a Model 1 like via a cassette program, or you might be able to make a disk image that's able to be loaded on, say, one of the business Tandys or something like that. And we'll kind of show a little bit of an example of that. So this is sort of what we're talking about, and most of our time today will be spent over in the modern system toolchain side. All right, so unfortunately we aren't going to cover all of assembly language here. I'll pass around so people can read these books. These are what I recommend to kind of, once you've got the tool chain, you can pass these around. People can look at them. These are 2 books I find good. So if you kind of get the bug and want to do this, I've got some code to get you started, and you can definitely do this. But suggestions to really learn this. Bard is my #1. That's this book here. If you put that into like an eBay search, these come up quite a bit, and they're not too expensive. McCall is another good one. It says TRS-80 made simple, but this book's actually got quite a bit more detail on like the ROM memory and things like that. So you can't learn it all in 45 minutes, but these are good places to really dig into it there. And we'll get a feel for the tool chain and its use, because one of the things these books won't tell you is the stuff that I'm going to go through today, how to get ZMAC running and how to run the emulator. So we'll go through that. All right. I'll switch to a little bit of demo mode. All right, so this is the slide I talked about. If you want to take a picture of this, or I'll figure out with the folks how to get this on the Tandy Assembly site. But this is all the code right here on GitHub, that's the address up at the top, Tandy Assembly 21 demo. And way down at the bottom, I have a link to the slides. So if you click on that, you'll get these slides. You can also get to any of those files. If you're not familiar with Git, if you click on any of the file names, there'll be a button called raw. And you can click on raw and just put the text so you can copy and paste it out of the web browser into your text editor. Right. Okay, so we got to start somewhere. And historically, Hello World, due to the C programming language, is a good place to start. So this is a very simple program. I'm going to actually bring this up live, and we'll play around with it. Got a little bit of space. Here's the code for this. We'll go ahead and bring up Hello. And I'm going to turn off the highlight. I'll make it a little bit easier for you. So there's some comments up at the top, and all of these programs will have the what to run to make them build and run in the emulator. But what we're doing is I'll quickly step through this one in a little bit of depth, and we won't go into the code very much. But the first thing we need to do is tell the loader where to load it in memory. And we're saying hex 7000. That's where we want this to load. I'm defining a couple operating system call locations because I'm going to be running LDOS version 5.1. And this is an output command, and here's one to conveniently exit. We're going to define what the character is to enter a new line. And then this is the first place we're going to generate bytes. We're going to put this string, hello TRS-80 world enter, and it will print. And we set up the HL register, and we come back to what the registers are. Call display, and then call exit, and that's it. And this should print hello world. So one trick when you do this, you have to get a little bit comfortable with command line, but don't just use one window. Have it. You can have as many as you want, so I can leave that editor up. And I'll go in here and let's, I'm in the same directory, so let's assemble that. And it's the hello LDOS 5. And there we go, we're done. So that's good. And what happened there was a directory we didn't have before. If you look at the directory above, we now have a thing called zout. And I'll go ahead and list it. And I'll explain more what this stuff is. But a lot of these are various cassette formats, both in WAV files and cassette, but others are command files you can put on disks. And another extremely helpful one is the BDS, which is for symbolic debugging. But we'll go ahead and run this in the emulator. TRS-80 GP, and we'll, what did I say to do? We need to run LDOS, which is -LD, and then zout on hello, and we're going to do CMD, the command file, which is what we run in the operating system. So George's emulator pops up, and he helpfully loads the program for us after the operating system has booted. And if you notice at the bottom here, we wrote ran hello TRS-80 world. So in a matter of seconds, you get from editing code in your editor to actually seeing it run in the emulator. This is really handy, but one problem with it is I can't run it again, and I'll discuss that in a minute. Right, let's go back to the slides for a second. Another file I'll mention is the LST file. Is very cool and good to know about. This is generated in that Z output directory, and it lists kind of the output from the assembler. So this is the whole program in a list file, and this shows you the addresses in member. Remember, we did org $7000, so you can see that's where the addresses are, and it shows you the addresses things are going up for. And you can see that it really didn't generate any code for these definitions. It just started when I put text and when I put code. So this is good to know about. It also is helpful for when you're really writing on like a 4K machine, you care about how big the program is. So it tells you how much memory you're using so you can know whether it fit in 4K or 16. All right, so let's expand this a little bit. We now want to do something more like what you might do in BASIC, like let's print out some things and ask what my name is, and I'll have it print my name. So go back to the thing here. Name. So I'll quickly get that a little bit better. So we're going to add a key in function here, and we also have a display with no new line. So all of this stuff, I didn't mention this in the last one, but I'm referencing the LDOS documentation here, and I actually put the page numbers where these various calls are documented. The other thing I need to do is have a small buffer, because we're going to input information, so I define a small buffer. And you can see several calls to display with hello world, name, prompt. Then I do the key in, so I tell it in the B register how many characters I can get, and then I pass the buffer, and I call key in. And then I do some output, and I exit. So let's switch over to our other terminal there, and we'll do ZMAC, the name. And then we'll run it exactly the same. In fact, I could probably just do this one. All right, so as soon as it comes up, now we printed hello world, but now it's sitting there waiting as it wants my name. So I'll type Tim Halloran. Turn it says hello Tim Halloran, goodbye from the TRS world. So this is still running an operating system, so you can still interact with the emulator, but it's really convenient to load up. So go back to that. All right, now let's switch to like, what would you do if you wanted to run this more than once? You can actually put these things on disk images and run them again. There are lots of ways to do this. There's the Fred hard drive emulator. There's various disk image formats. There's some command line tools. This is probably a topic worthy of its own tech talk. But I'm going to show Tris tools, and I'm a big fan of Vernon's multi-DOS. So we're going to actually do multi-DOS because it'll run these programs. So we'll use Tris tools, which I think I have running. One thing I will tell you is please open, like make a copy. Here's my multi-DOS. I made a my multi-DOS. Don't like do this in the download version. So if this is an eye chart, you can't see it. These are the files that are there. So what I'm going to do is actually add the new files, and I'm going to go into my my zout and find the two command files, the hello, you have good eyes if you can see what I'm doing. Really. So name and hello. Now one thing it will do is tell me I need to make names that will fit in the TRSA because these file names are too long. So we'll just do hello.command and we'll do name.command. Right. So, whoops. Now we'll go run the emulator again with that. Oh, I need to close the file. Thanks, Jeff. Let's see. Dash D0. Oh, I want to do a model 4. So we're going to say model 4, and we're going to do in disk 0. I want to put my multi-DOS. So this is going to start a model 4 emulation with my boot disk in there that I just edited. So we get model 4, and of course it doesn't know the date and time, so we'll call it. Okay, now it just came to the prompt. That's because this is a disk image. So if I do a directory, you can see hello CMD and name CMD are in there. So let's run hello. And that does what we expect, and we can run this as many times as we wish. And if we want to do name, we can do name. And we're back at multi-DOS. So this is also the way, if you're a business system user, you need to do something like this because there is no cassette cable to get you onto your system. You need to get it on a Protec or a HTC or something. So let's see how it's going on. Okay, good. That's that. Back to the slides. So again, don't worry that all the details, but just get the impression of how this is done, and feel free again to reach out on Facebook to me and the Phillips brothers and things like that. Lots of folks will help. We really hopefully get people excited about this work. Okay, but let's shift gears and get serious. The Tandy Z80 line had a lot of serious business systems. So the Model 2, Model 12, Model 16, and 6000 to a degree, but I'm going to mostly focus on the Z80 side. So I have a little program which is using LDOS 6 commands rather than the LDOS5, and it works slightly differently. It's a little hard to see on the slides, but we call, here, I'll bring it up on the business demo. Okay, so common syntax. Okay, so the only real difference here is they have slightly different convention for calling operating system calls. Display and exit are familiar, but we load the text in HL, but then we load A with our call number, and then we call RST and the 40, and this invokes the operating system call. It's just a convention. So we'll vmap that. And then we can TRS-80 GP-model2, for example, and we'll go the business. So this should start up a Model 2. Some of you are familiar with Model 2s. This looks good. Oh wait, I need to run LDOS. Sorry, my bad. I messed up. That was Tristos. Let's do LDOS before we do that, because that's the operating system we wrote code for. One of the fun things about this Z80 world is there's a ton of different operating systems. So you can have a lot of fun writing that. And in fact, I do have an assembly language program I'll mention, the Z80 unit that I wrote for testing, which supports a lot of them. And it was really fun to get those to work. And sure enough, we can see at the bottom that we have Hello Business TRS-80 World on our Model 2. So this is working as expected. So indeed, a lot of the, George's emulator supports the business systems really well, and CMAC is a great tool for developing things. Let's get back into this. Kind of picking away at stuff. We won't spend a ton of time on this. This is one you have to do, but I have a little add.boot program, add.assembly, and it does some 8-bit math and some 16-bit math. And I want to show you George's debugger, because you can step through this program. It does no I/O, so if you run it on a real TRS-80, it's not very useful, but you can see things. I believe the next slide has this. So this is an important one. Definitely wanted to bring this up, and I wanted to show it to you in George's UI format, because the registers are very important when you do assembly language. You have memory, which everybody's heard of, but these are your scratch within the TRS-80, and we have the AF, BC, DE, and HL. For each letter, there are 8 bits. With the prime ones, but we won't worry about that too much for this talk. That's sort of an advanced technique. 2 of the registers that matter a lot are the A, which is the accumulator, and any 8-bit math you do tends to end up in the accumulator. It's sort of a special register for that as a scratch pad, and HL serves that purpose. For 16-bit things you need to be aware of the HL register. It's sort of special. So most calculations require data in a register to do an assembly language operation. You can't do it directly from memory in the Z80. All right. So we'll definitely quickly fire this up just to show what it's like. We'll ZMAC the add program. Whoops. Add. All right, and to run this program, I'll bring it up just to make sure I don't do it. So we want to do TRS-80 -E, and I'm going to talk about what I'm doing here. I'm actually doing symbolic debugging with George's emulator. So, all right, so we'll TRS-80. We're going to -P for a breakpoint. We're going to break in our main program, and I'm going to run zout add, and I'm going to use BDS, which is symbolic. So if I didn't have the symbolic, I'd have to type a hex address of what the address in memory that I want to breakpoint at. But this will fire up a Model 3 in debugging mode, and I already knew this ahead of time. You're never going to be able to see this. So I highly recommend sort of firing this program up and doing it. But what you would do is actually follow along in the source code. And this is stopped at the very beginning, and we can see the source over in this panel on the right-hand side. And I can just say step, and you can see maybe a little bit that the thing is moving through the program. And it will do the operations, and it's updating the entire state of the machine over on the other side. You can investigate and make sure it does doing what you want. Now, this particular program resets itself and then jumps back to the top. So you can go through this as many times as you want. I encourage you to modify the program and make it do whatever you want, and then sort of practice doing symbolic debugging. There's a lot of power here we don't have time to do. You can put in addresses and examine memory. You can do various breakpoints on different things like various portions of memory being accessed, things like that. It's super powerful, and you just realize this is here, and it's great to be able to use this. Let's see. This is kind of a fun demo. Cassette loading fun in games. I mentioned the org call. This org, which loads it into where in memory do you want the assembly language to go. Some of you may remember the Big 5 games had really interesting, when you loaded the cassette, the screen sort of filled up with stuff, and it was really interesting. So how did those guys do that stuff? So I wanted to show you how that was done. The way they did it was they had multiple org calls in the same program. So let's switch over to the editor. Org fun. All right, so what we do is we can have as many of these orgs as we want. And in fact, we'll talk about what the memory map is, but this is an important one in a like a Model 1. 3COO is the memory address for the first position on the screen, and then there's 1K of bytes that actually, anything you write into that memory will show up on the screen. So the first thing I'm going to do is org to the screen location and put 64 by 16, that's the number of columns times the number of lines, and just write a blank space, which I should have put space, but I did $20, that's the thing. That will clear the entire screen. Then the second thing I did is I org to the screen plus 64 times 5, which is the start of the 6th line on the screen, and I defined some bytes that say hello TRS-80 world. And then I did the same thing on the 7th line, and I just said, this is how Big 5 did fancy cassette bytes. And then I org to 5200, which is a more conventional place to run programs, and I'm gonna just pause until the machine is rebooted. Now here's a little recipe down the bottom of this program that George Phillips gave me. This is how to do a cassette auto start. So if you don't want the cassette load to give you a slash and you have to hit return, you can org to 41E2, jump to the HL register address, and then end your program. And this will automatically start your code. So we'll actually give this a try, just so you can see what it would do. ZMAC, org on. All right, now this is going to be quite a fun thing to put on the command line. We will paste that in there, but the command line here is we're going to say no disk. I don't want a disk, so DX, and I'm going to load in the cassette my zorg fun 1500.cas. So I'm going to load a cas file. Now when this starts up, it's not going to do anything. It's like sitting like you would turn on a machine. So I'm going to say, fine, I want high-speed cas, and I want memory size, and I end up at basic. Now, many of you will know to load a cassette, I type system, and I'm going to type O because it's org fun, and I only need the first letter. So now we'll actually get to see that org thing like the old Big 5 games did. So you'll see the screen clear, you'll see it org to my location, and it will actually run the program out it's done, which doesn't really do anything, but you could run the program and use the thing. So that's kind of a fun one of like what the orgs do. All right. Let's go back. And I did mention the memory map. You can find these online probably better. This is one I use. This is the Model 1 Level 2. We notice I'll point to it. We just play around with this area of memory, 3C00 through 3FFF. That's the video. But the keyboard is also in there. There's other things, and there's RAM and ROM of various things. And knowing where these things are when you write these programs, when you start out, you don't need to know a lot about this. Maybe the video is a good one to know, and being the keyboard, but it's good to learn about this, and they vary from machine to machine. All right, a final demo. I did wanted to show some code that's a little more towards like something real. This is I made Space Invaders, but with little figures that look like LEDs, so I called it LED Invaders. So it's a classic game, but with electronic components. So what I'm showing here in this code is call and return. These are sort of subroutines, and they let us better organize our code and give meaningful names to bits of code rather than just having a whole bunch of go mode A, this, that, and the other, add one, increment, that sort of thing. We can have things that the main thing. So this one clears the screen. It can draw an entire screen, which is various draw frames to get 7 of our LED invaders. Draw frames probably not named very well, but it kind of draws one invader out of position in the screen, and it draws one frame of the animation and then 2 frames of the animation. Then if you didn't do the wait, it would go so fast it would look like a blur. So we actually do a little bit of pause to do this. So let's go ahead and before I'll show you the code, but I'll go ahead and this is more fun to just see what it does. So let's zoom out this one. LED invaders. Right. And here's LED GPUs. Let's go model 1 on this one and Z out LED invaders, and let's use the BDS. BDS by default will go to a cassette load, so we'll go ahead and use that. And here we go. That looks like something you might poke around with a little bit more. So this is a little more toward a real program you might have some fun with, a little bit of animation and that sort of thing. So show how that is done. And of course, all of this code is out there. Please feel free to dig into it. And we're going to show this. Let's skip what this stuff means. But each of those little ships, each of those little ships are 3 characters by 2 lines. So this is the graphics plates. And I'll show that in the slides in a second. But here's the code to clear the screen. Thanks to George Phillips. This is a really tricky way to do that, but it's encapsulated in a little call. I don't normally do it that way, but for this presentation, it's nice to have it all self-contained. There's the draw frame with some comments and drawing the screen. And all the draw screen is you can see the 7, just repeated 7 calls to the draw frame. And then we have our wait call, which somebody calls, and then we have our main loop. And you can see it calls clear screen. It defines animation loop and draws frame 1 of the animation, then frame 2 of the animation would draw screen, and then it jumps back to the animation loop, so it continues to kind of run that animation through its 2 frames. So this is an example of sort of organizing your assembly language a little bit, such that you're kind of have calls and can keep things together. Give things names so you can understand what they're doing in addition to your comments. All right, and the graphics character code might have been like completely incomprehensible. That's because it's really odd on a TRS-80 Model 1 and 3 how this is done. It's you set the highest bit, this bit 7. And when you change that to a 1, then 0 through 5 are interpreted as graphics characters in 2 wide and 3 high. And this is how the blocks are done. But this allows you to mix graphics with normal text, because if you set bit 7 to 0, you can just write a normal character to the screen. This first chart is the one I use a lot. It's out of Barton on page 175. That's this book. And this is from Wikipedia. It sort of shows the same thing. It also shows you how it sort of fits onto the screen. So you can do these sort of things, that sort of thing. But this can kind of be a little bit painful to kind of map these out and figure out what you need. And that's what I was doing in my program, up at the top where they had those frameworks. To finish up, let's see. Okay, pretty good. These are just the output files, and I did want to show, I've got this up. George's site has a tremendous amount of documentation. So here is George's site on ZMAC. You can download it in the upper right-hand corner, but this is all the instructions about various things you can do. And this is very well done. It's very terse, but it's very precise. So a lot of the information you need is all here. And one of the bits I wanted to highlight was, sorry, let me get this back up. The outputs of the cassette files are pretty complicated, but if you can't remember whether you need .1500 CAS or .250 or .500, go to George's ZMAC page and read the documentation on these, because there are several files for cassette. The CAS files, which are encoded version of the audio, and then of course the actual WAV files themselves if you want to play it out like with a play command or on a phone or something like that. We've talked about the BDS and the command files, so it can be super helpful, but that's good. I'll also mention there's another even longer page on the emulator. So anything you need to know about this emulator and how to get it up in a particular mode There's tons of documentation. Again, very terse, but very precise. It's probably there. Also, you can get help from the community as well. So we'll kind of finish up and then ask questions. But I did want to include, these are mostly so that this is in the slide things. One of the questions I asked George Phillips was, I wasn't sure how to debug a DOS program because DBS, the debugger format by default, goes into cassette mode. If you want to boot an operating system, then debug. In fact, what you do is you pass like LDOS, break at main, and then pass the command file first, and then L-L load the symbols from the BDS file, and that will actually start doing the debugger, and you can debug your DOS programs. So thanks to George for showing me how to do that properly. The other thing, which is more advanced, if you write big programs, you're going to want to put things in separate files. This slide shows you how to do include files in ZMAC. So you can use the import command to import in files, and you can put as many of these as you want to separate your code into separate files. And I'm also showing you how to do, if you're at all familiar with like modern programming like C, a header guard checks that your include only happens once. So this is how in ZMAC you do a header guard, and this would make sure that include guard and fill, like if I include guard and fill, if I do it 19 times, it will only include that code a single time and then skip all the rest. This is more useful than you might think. And I have lots of examples out on my site of doing these sort of things. The other thing I'll note is why would you put these in include files? Well, you might want to test them. I created a Z80 unit test system a few years ago. Here's the link to that. If you are doing big development, this is extremely helpful to make sure components in your system work. And that's there. So this is way advanced, like I said. But if you just remember these things are there and keep these slides. If you ever need them, folks will be there. So with that, I'll sort of wrap it up and I'll put the thing back. But I definitely want to open it to any questions folks might have.
Could you give us an example of an error message that comes up when you're debugging?
When you're debugging?
Or when you're actually, like take one of your examples programs, maybe make a little error.
Oh yeah, sure.
Show us what actually happens.
Yeah, that's a great question. So we can, let's go into, well, we've got LED invaders, so let's go in there and bust that. So suppose I did like, I'm copying the screen address of the screen into HL to secure the screen. Suppose I did one typo we might do is type type H1 instead of HL. So if I ZMAC, and let's actually do this the way I showed you, because you would actually not want to edit the editor. Stay there, and we'll go ZMAC. And those LED invaders. So, there we go. It goes syntax error at line 33, load L1, H1 is undeclared, so it doesn't know what that is. So I would go to my editor and look at 33 and ponder this and go, what did I do? And then realize, oh, H1 is not the register, it's HL. So of course people could, if you really wanted to, you could use capital letters, it'd be less obvious. So we'll go ahead and do that just to make that change, write it, and we go back, and ZMAC will go through that. So if you can quickly go through that. Yeah, that's a good question. Thanks, Jay, because you will definitely see a bunch of these.
Yeah.
Even when I do it, I definitely see a bunch of these. So it's really any others?
Yeah, Tim.
Go ahead.
I have yet to use ZMAC. My ridiculously huge utility that written for music says MRAS.
Okay.
And I noticed some incompatibilities with the code. For instance, the $sign syntax for hexadecimal
Instead of H
instead
or
of H.
that'll work fine. It will probably work fine in ZMAC. And if it doesn't, George is probably interested. Because I know from talking to him, he is not just interested in doing modern code. He's actually interested in being able to compile, older code and different kind of code bases. So if there is a limitation of ZMAC, please reach out to him and let him know that like something you're trying to do is not behaving.
Yeah, I'd like to convert to that methodology soon because it's obviously a lot quicker. I've so far been compiling, assembling everything actually on my GRC.
Yeah, in fact, if you look at his page, it'll document all of these. You can use dollar, the number for hex. You can use HFN for hex, which is actually how Barden does it, I think, in the book. And you can also use the modern like 0x, like more like C-oriented syntax is perfectly welcome. So, and most likely, if you come up with another one,
I use a large number of the MRAS macro facilities.
yes.
And I wonder if those are.
I suspect they will work, but again, George would be interested. I got into the macros pretty heavy because the Z80 unit does tons of macros, and it's pretty amazing the support he's built in. I don't know the whole history of ZMac, but I know George didn't start this. This is a much older project that he sort of picked up and expanded.
I guess another option to make it faster would be to actually run MRAS in an emulator on the PC rather than on the TRC.
Yeah, well, definitely. I'll do that. Yeah, definitely. But yeah, I think this is fun and it's reliable. Your code doesn't automatically delete itself. You don't have to go make cassette backups versus, work on the TRS-80, I think, for serious assembly language is really, really hard to do. I mean, if you're dedicated, you can pull it off, but I suspect you will give up fairly soon for big programs. Like one's being demoed. Peter, did you do yours on the TRS-80 or did you actually do it in ZMac? Yes, so to do he's got a great game over there, please check out his demo, but like big projects like that, this is much nicer. Like I said, in Brooks' terminology, we separate all the accidental tool complexity from the essential and focus on the code. Other questions?
Is there a little ZMac disassemble?
I don't know. I've never played with that because most of the time we have the code. But you can definitely use TRS-80 GP can disassemble parts of memory and show you things. I'm not sure how sophisticated it is because part of the problem is figuring out what's data and what's code and then separating out self-modifying code and things like that. That's not something I'm expert in. Maybe Post and George might tell you more. Sadly, the Canadians could not be here, so he's not. He would be sitting probably right there. He would know. But I don't know. I've not done a lot of disassembly. Mostly I start and write new code and little things and try to do it. Let's go ahead.
Just like a comment. There's a guy in Discord who's working on this. I can't remember who it is.
Cool.
But he was looking for a list of addresses because he wants to be able to code calls and wrong.
Oh, that'd be cool. Yeah, get them all down. To do a really big database.
Matthew Reed has this assembler.
Yes. Oh, I forgot about that one. That is Matthew Reed is definitely a check. Wow, he's gonna have a project because mapping all the DOS is impossible to deal with. And just that in itself is a project. Any others before we wrap up?
When it comes to compatibility, is there any particular guidance or limitations to say, well, if I wanted to run on 1, 2, and 3, I got to do it this way, or is there an expectation that if I created a little program for a Model 1, it would work on a Model 3 and 4 automatically, or 2 automatically?
Yes. For very simple things like all of these programs I've done, unless they're for specific, like I did LDOS 5 and LDOS 6 programs, those are going to only work on machines that can run those operating systems. But most of the rest of those programs would work on Model 1, 2, 3, 4, and maybe even Model 2. Model 2, not so much because the ones where I'm poking at the screen works a little differently on business systems than it does on the Model 1 through 4. Most of the time, you're probably gonna, make a conscious decision because there is additional hardware from the Model 1 as you move to the Model 3. You can now use a timer interrupt, and these are I know every 1/3 of the second things are going on, whereas the Model 1 can't do that. And then there's Model 4 has a whole bunch of things like the 80 column mode. So if you develop such that you're conscious of the hardware you're using and make sure it's available on all those, and it is super easy because you can say, my program dashed in 1, does it work? Dashed in 3, does it work? Dashed in 4, does it work? So it's super easy with the emulator to be testing on all the platforms you want to support to make sure that whatever you're trying to write, if you want it to work on all of them, it can work on all of them. Yeah. Anything else?
Did you find that there was any consistency with calling the different routines in the OSs? I assume that their entry points are all different.
They are, but some of them work, like LDOS 5 and multi-DOS. I didn't change any of the code. I literally put the thing. I haven't figured that out. It's kind of fun to like, I wrote Z80 unit and put all these different, there's like big macros that handle all of the operating systems. And that was really interesting. That was my first foray into all the different calling conventions, but they do differ. There is some consistency, but I think it's a tall order to write something that like supports a ton of operating systems like Z80. And I'm not familiar with too many programs that do that. So other people might be, I'm not sure that there is builds, but it is possible to do. Like for something like a text adventure, you could easily like copy all the stuff Z80 unit did to support all the different OSs, because then you got a thing that lets you output to the screen, print a new line, input some text, print a string. It has all the pieces, parts for simple things. But to do something like LED animation we did at the end there, that's a little trickier to get going on all the systems. Anything else? All right, well, I'll finish up with a call, like George and Peter and I and other folks, Peter back there that are doing this. We definitely could use more assembly language folks in the Z80, so you're most welcome. Grab the stuff online and have fun. Enjoy. Happy hacking.
Then you gotta get George to do a talk on just TRS-ATP itself. That would be nice.
You could.
He should. All I want to get Zoom.